Hi everybody, it's JJ back again, and we're having a really exciting actually live stream today to be able to go ahead and kick off essentially kind of an early announcement here to be able to align with Intel's latest and greatest platform launch for real advanced professional users, and that's going to be with the latest generation of CPUs from Intel under their Xeon series of processors. So many of you that are of course PCDIY enthusiasts might be familiar with, of course, with the standard lineup of the Intel Core series here, but now we're taking a look at actually Intel Xeon based processors, and these are really kind of focused for users that are going to be in professional portions of the market, working from everything from science and simulation to CAD to advanced media production, virtual effects, simulation, and many other kind of elements. So really excited to be able to actually talk about this platform. We've been really working hard to be able to offer two fantastic solutions for the brand new chipset and platform. So W790 is what we're going to be talking about. So we've actually got two different boards that we're going to be going into today, one with our Sage and another with our Ace. And we'll also be giving you guys some insight in terms of hopefully understanding some of the updates that we're having going over to this new platform, the new chipset, and kind of features and functions. And again, priming you so that you have a good understanding that if you're looking to adopt and build into this workstation platform, you hopefully have all the information you're going to be looking for. And as always, if you guys are looking for more information, make sure to go ahead and check out either our edgeup.asus.com website. You can also check out the corresponding product pages. They'll be linked in the description. You can also feel free to join us in our PCDIY group, which will have more information regarding these motherboards. All right, fantastic. So we've got a few people joining us here on the stream. We've got Brian, Michael, Erica, fantastic. Thank you for letting us know so much. We also have actually an ASUS team member. Jake there is also in the chat. So there may be the opportunity if you guys have questions and I'm not able to go ahead and field them, feel free to go ahead and let us know in the chat. And as always, you can follow up with us in the ASUS PCDIY group or go ahead and reach out to us via our social channels. Also got Sumin and H2O Computers joining us. Fantastic. So let's get ready to go ahead and jump into this. A lot of really good information here. So first and foremost, let's go ahead and just kind of dive into a little bit about what's new here. So we've actually got a lot of changes when we talk about this. There hasn't been a kind of an update within this specific kind of high-end enthusiast desktop space for quite some time. The prior generation, you had the X299 based chipset, and now we've moved over into W790. Now with W790, there's going to be quite a number of changes that we're going to be bringing in, and so we're going to go ahead and be talking about those. Let me go ahead and first and foremost, though, I think break things down from a perspective of taking a look at first kind of the CPU, right? The CPU, I think, is a very big part of this conversation because it drives so much of the overall kind of experience, feature set, and the functionality. Again, we're going to kind of recap a little bit here in terms, I think, of one, what are you taking a look at here? So these are going to be featuring Xeon-based processors. So if you're not aware, kind of Xeon is going to be the workstation series processors. So you generally kind of break things down in 3 different segments. You would have, if we're not counting mobile, you would have kind of your traditional desktop, which would be defined by your Core series processors. Many of us are familiar with those, you know, a Core i3, a Core i5, a Core i9, right? Current generation is going to be, you know, a 12th gen or 13th gen series, so Alder Lake or Raptor Lake. This is going to be Sapphire Rapids. These are actually going to be utilizing Golden Cove, which is essentially the same kind of microarchitecture and cores that we saw within the P cores that you had within kind of 12th and 13th gen series CPUs. So this is a very big transition update for the workstation platform to bring about essentially this brand new microarchitecture with new performance, a new memory controller, and a lot of new advancements that have really been kind of in development for years. So really, really exciting in that part. Now, segmentation, we're going to talk about that in a little bit, but really kind of the focus is going to be here for more professionally kind of inclined users. So users, again, kind of working in science and simulation, VFX, advanced kind of development platforms, right, that require a high number of cores, right, and also robust processing, as well as maybe specialized instruction sets, because we're going to talk about how things that like AVX and AMX technologies can really help to improve upon the performance that you'll have in here outside of course, other specification support like robust PCIe and memory storage configurations. So specifically for this generation, we're going to be seeing the introduction of essentially kind of 2 CPU parts here. We're going to have the Xeon W-3400 series, and then we'll have the Xeon W-2400 series. And you can kind of break these down not only in terms of the number of cores and the PCIe lanes, but also in terms of power. Power is a big kind of defining portion in terms of kind of the CPU and how it ultimately operates and the performance that it can provide. And so that's where you see it kind of segmented out here, where you have up to kind of this 350 watt designation and then 225 watt designation. Now, in terms of the number scheme or kind of the model scheme, this is going to be pretty similar to what you see again in Core series, where you have things broken down between the W3, W7, W5, and then when we move into the 3400 series, W5, a W7, and W9. And so essentially, as you move up within that W rating, right, you're of course going to get a higher performing part. Now, there are going to be some differences definitely compared to traditional CPUs in terms of the core lineup. So take, for instance, we don't have E-cores here where we had like E-cores within Alder Lake and Raptor Lake. Here, we're essentially only looking at performance cores, but you do have hyper-threading. So you are going to be talking a very high level of performance resident to the CPU cores that you have here, and then also a very high number of cores and total threads. So cores, you know, you're talking about on the top end spectrum here would be 56 up to 112 threads. So very, very, very advanced processing capabilities that you have based on those Golden Cove cores that are going to be present here. All right. Now, next up here, we're going to probably take a little bit of a closer look at kind of understanding some of the platform kind of updates that we have. So let me go ahead and bring this up here, guys. And I think this is going to be right here. Yeah. All right, perfect. So when we're taking a look at the overall platform here, and in a moment, if somebody kind of has some questions, I'll feel free to go ahead and jump in there and kind of check to see as some of the information I'm going over can be clarified here. So as we noted, right, again, with the Xeon 24, you're going to have up to essentially those 24 cores, right? Again, remember you do have hyperthreading, and then the W3400 is going to be up to 56 cores. Now, there is also going to, of course, be differences as always that you need to count for frequency, right? We are seeing a nice frequency uplift for this generation because we've got those Golden Cove parts. But as always, you've got like Intel Turbo Boost technologies, which either Turbo Boost 2.0 or 3.0 that you need to account that depending on the workload, of course, the clock frequency will vary. And this is also going to be another big difference is you're taking a look at some of the CPUs, and we'll take a look at the actual kind of CPU matrix to kind of get a sense. There's a pretty big difference between sometimes the base clocks, so the minimum operating clocks, and then kind of the boost clock configurations. So as always, you kind of have to match the CPU in alignment with what the workflow or the work usage might be, right? So you can see here up to 4.8 gigahertz. That's of course a nice uplift compared to the prior generation. You've got the robust smart cache technology. Now this architectural design is a bit different than what you have in terms of Intel kind of Core series, where in Core series you have what is referred to as a ring bus type design. For this, actually you have something that's called a mesh based design, and the mesh based design really allows for Intel to have this scalability to package in essentially the high number of cores in the design that you have present in here. So some really interesting elements in that. It does change kind of the way that certain aspects of the kind of the CPU works, but it allows for kind of the scaling to occur. So that is just kind of something to keep in mind, is that some things you might be wondering about, like, how about ring bus? It's different. You have mesh versus ring. So those are going to be separation. You also have a little bit of a difference in terms of the designs here. Not a little bit, but actually a fairly large difference here. With the Xeon W-2400 series, these are going to be designed using a different process. So kind of traditionally what is called a monolithic design process. And for the W-3400, you're going to be looking at actually a new process, which is utilizing technology called EMIB, which we'll note on a little bit, but it's essentially an advanced way that they're able to package in the CPUs together in a kind of a single package, which traditionally in the past you would have had to like have multiple sockets to scale up to so many cores. But here they're actually able to package them together and be able to offer very, very performant, essentially, type of design. Big update here is also going to be the support for DDR5 memory. Now it's important to note that here the DDR5 memory will not be interoperable in terms of what you would have like on a traditional desktop. So here next to me, I've got a Z690 based platform, Z790. These are going to be using a different type. You have to use DDR5 ECC RDIMM based memory. So it is specific memory to the W790 based platform. Although there are some enhancements, including actually overclocking support that we'll be touching on a little bit later. So you will actually have the opportunity for overclocking not only your memory on this platform, but also the CPU with specific overclock or unlocked essentially CPU models. This is quite a departure from most Xeons that have been released in the past, where traditionally you have not had overclocking. So again, if you're looking to even extend performance further, this platform really does kind of align with not only the performance that a high-end enthusiast would require, right, but also for enthusiasts that appreciate the granularity and control, will have options there. You're going to have ultra large memory density support. The IMC is quite robust. You can see up to here, depending on the density of memory, it's not even available yet, but up to 4 terabytes in terms of memory configurations. Right now, the official kind of max validation is 2 terabyte configurations. And depending on the CPU, either here in the W24, you will have up to essentially 4 channels. And then on the W34, you'll move up to 8 channels of memory. So we're talking massive amounts of bandwidth. And this is critical because you need essentially bandwidth to provide to each core. And so this is often overlooked in terms of the discussion between DDR4 to DDR5, where people want to compare things just like maybe timings, sometimes latency. If you pair what's called JEDEC to JEDEC, so official specification standard support, DDR5 always will win. It will always provide a better performance. And within the workstation world, because generally you didn't run things out of spec, you were always looking at standardized specification support. It was always a clear value proposition. So here it's exciting to not only be able to get the efficiency improvements in terms of lower voltage, right, increased bandwidth and overall higher performance, and more bandwidth per core, which is critical for such a high number of cores. Again, we're going all the way up to 56 cores and 112 threads. And here, lastly, in terms of the platform, quite a number of updates. Again, if you're coming from a much older platform, you're going to be seeing, of course, the big update is going to be support for PCIe Gen 5 with up to 112 PCIe Gen 5 lanes. So this is massive, and this is the reason why with our motherboards, you're going to be seeing boards that have such a number of PCIe slots to allow for really, really bus expansion support. So this will not only take advantage of things like graphics cards, but dedicated accelerator cards, specialized storage expansion modules. There's even things like CXL, which is actually supported on this platform, which could actually allow you to essentially have kind of upgraded memory pools that could actually be connected into certain buses. These aren't necessarily available on the market yet, but this is a foundational kind of technology that's being built into the platform, supported by the CPU, and you'll see more of this over the coming really months and coming years, as generally for this type of platform, you're talking a much longer life cycle, right? So pretty crazy. In addition to that, we've got, of course, advanced networking specification support with, of course, robust options like 10 gig networking on the models. We'll optionally have M.2 Wi-Fi support, so you can slot in up to a Wi-Fi 6E based module on the boards. And there's also been an increased DMI link. So the DMI link essentially is going to be the connection between the base chipset and the CPU, right? And so when you're feeding information, this also sees an expansion there in terms of the bandwidth that can be provided. So ultimately just giving you more performance. So really across the board, whether we're talking about the CPU, the IPC, right? So the instructions per clock, right? The overall architecture, the Intel 7 nanometer process, kind of every single thing is going to be upgraded. So if you're coming again over, this is going to generally be target maybe at users that are in that X299, maybe X99 category, then this is going to be a huge uplift because you're really kind of getting all of the big benefits that have been offered on platforms that say like Z690 and Z790. But if you've been looking for even more cores, more threads, more PCI Express lanes, and more memory density, as well as support for things like, more specialized instruction sets like AVX 512 and AMX and things along those lines, then you finally have a platform that will be available to you. All right. Now, before I kind of go into the next segment here, I do want to just go ahead and check to see if we've got a couple of questions that might have popped up there. Hey, Depo, it's happy to have you here. Thanks so much. Yes, definitely 10 gigabit networking is going to be present here. But of course, with that robust storage expansion, we definitely know that actually from discussion that we have from many of our system integrators and professionals in the space, 10G is really kind of the minimum starting point. We have a lot of professionals in the VFX arena that for instance, are actually using 40 gigabits, 100 gigabits, right? And so they need to be able to have robust PCI expansion storage so they can drop in those high performing, single or dual or even quad gigabit Ethernet adapters running much higher base configurations. And so here, the number of PCI lanes really gives you a great deal of flexibility, right? Very cool right there. Let me just see any questions right there. All right, doesn't look like we have anything there yet, so let's go ahead and keep moving things along here. So I quickly want to just kind of touch, I'm not going to spend too much time on it. You guys can check out a great video and we'll link it in the comments here in a little bit if you guys want to check it out. But Intel does a little bit of a deep dive to actually talk amongst their team and their development team to note actually a little bit about the EMEB. And so the EMEB technology is quite interesting. This is actually this right here, this interconnect bridge, and it is actually what is utilized to essentially allow these multiple portions of the dies that are present to essentially talk to each other. Because again, in the past, you would have had literally like one or two sockets, right? And essentially two sockets with two sets of CPUs to be able to actually get to this higher number of cores and threads. But going through the EMEB and the mesh configuration allows you to essentially now have them essentially within a single quote unquote like CPU package, right? And have essentially better latency performance than you would have compared to, let's say, like a two socket based design, right? And so this is a really cool technology that is present now within the W3400 series and is what is allowing for the performance and essentially kind of this big push to be able to offer this high number of kind of cores and threads within the CPU. All right. Now taking a look at this kind of little block right here, before we start getting into the motherboards, don't worry guys, I know you're going to be interested in here, but since the CPU determines so many interesting aspects here, I want to make sure to go ahead and touch on this, is that here, again, we have a little bit of a breakdown that on the 3400 right up to 112 lanes there, you can see in the W790 chipset how you also then have, of course, lane allocation broken up, including PCI Express Gen 4, PCI Express Gen 3. Status support is still there. Of course, we have robust specification support for USB 3.2 Gen 2 by 2, so that would be up to 20 gigabits. So both of the boards that we'll be talking about do have those connections. And then, of course, supplemental, of course, technology and I/O specification, which is supported by the chipset. Now here, when we're taking a look at the W3400, and if we compare this here to the 2400, let's go ahead and just bring that up side by side. So just to get a little bit of a comparison difference here, keep in mind right here, again, W3400 is going to give you up to those 8 channels of memory, right? And you're going to have up to the 112 PCI Express lanes, right? And then if you're going with a W2400, you're going to have 4 channels, right? And that's going to be up to 64 lanes. Now that in either configuration, right? Of course, with the W3400, it's significantly more than you have with Z790, but even with the 2400, it's significantly more. Now, on the more entry side, this will be the conversation of kind of going, would you build something with, let's say, because here you have, of course, up to the 24 cores, and then you also have the hyper-threading. Would you build on something like this, or would you build maybe on Z790? And again, it comes down to your workflow consideration. Do you need essentially these additional lanes? Do you need more memory density? Do you need more memory channels, right? So these are going to be factors that you need to keep in mind in terms of deciding which is going to be the right choice for you, right? Okay. And go ahead and take a look here. Again, so this is, again, just giving us a little bit of perspective on the W24, right? terms of the memory density, we talked about that. Keep in mind here in terms of the speed, again, these are ECC RDIMM based modules, 4800. As always, rank, density, and population affect the overall operating speed, so you have to look at your technical specifications as you increase that. You do have, of course, overclocking support that will even come later in the form of actually XMP related RDIMMs. So do keep that in mind for those that are going to be, of course, interested in overclocking support. And again, here on the 3400 side, pretty much the same thing. Now, some people might ask, if you're not familiar, just keep in mind Xeons do not offer an integrated CPU package. Do not offer an integrated graphics design. So you do always have to use some form of a discrete graphics. Now, both of the boards will have an out-of-band management option, so there will be flexibility in terms of having these as kind of a headless type of workstation configuration, if that is something you're looking for. But traditionally, in talking about setup, depending on your needs for the GPU, you will still need a discrete GPU within these systems. Okay. All right. The ACE is actually already up. I'll be sharing the website in a moment here. We'll be having it up on the North American site in the not too distant future. They are already up and running right now on our global website. So those are already up there. Okay. All right. So let's go ahead and get into the next portion here. So I think the next thing I want to kind of quickly talk about is series overview. So where does the WS sit within our motherboard lineup? So if we kind of just quickly cover our motherboard lineup, we have our Prime series, we have our Tough Gaming series, we have our ROG series, which actually there's two ROG series. There's ROG Strix and there's ROG, what we refer to as formal. So like for Intel, that would be, take for instance, like the Maximus series. So that's technically 4 series. We then have our ProArt series, which is, I'd say, similar to the WS series, but with a more kind of prosumer and hobbyist narrative for kind of creators and ones that don't necessarily require such advanced support for more kind of professional features that are going to be present on the WS. We also have our CSM series, which is our corporate stable model, which is designed for a wide range of verticals from kind of small, medium businesses to enterprise to commercial to government installation. And then we have our WS. So WS is workstation, and we have actually had our workstation series actually longer than we've even had ROG. So for more than 15 years, it is a cornerstone of ASUS's motherboard lineup. And you're not going to see it offered within, of course, entry-level chipsets or more basic offerings. And that's because its intended performance target is going to be much higher, right? It's serving the demands and the needs of a professional. And you're going to have support, like I said, for advanced features, whether they're going to be things like on the networking side, vPro, ECC memory support, specialized chipsets, including chipsets that are designed for ECC or for Xeon CPU support. So that is kind of some of the segmentational difference. WS, in terms of kind of a hallmark, one of the key hallmarks is going to be robust expansion support. So that's going to be in alignment with things like having more PCI lanes available to you, robust IO, things along those lines, right? So that is going to be just a little bit of kind of designation in terms of how the product stack sits. Okay, so let's get ready to go ahead and I guess talk about these boards here. So give me 1 second and we will get this to go in here. And so just for reference here, I will show this to you guys just so you can kind of, again, get a little bit of a quick kind of perspective. You're kind of wondering here, again, series overview, right? Prime series, Tough Gaming series, ROG Strix and ROG, ProArt, and then our Pro workstation, and then our corporate stable model, right? All right, so let's get ready. Which one do we want to talk about first? Do we want to go for the ACE or do we want to go for the WS? I think, maybe let's start off with the ACE. The ACE being the, I don't want to say more entry, but it will be the option that is probably more targeted in alignment with, take for instance, let's say the W2400 series. Technically, you could run either CPU configuration within this, with either one of these boards, so W24 or the W34. But based on kind of the number of PCI Express lanes and the memory channels, right, ideally, you kind of one board would be more suited towards one CPU configuration than the other, okay? And so let me go ahead and bring this up here. And we were going to take a look right here. So this is going to be the Pro W790 ACE. And I will link the website here in a little bit. So we're going to go ahead and talk about that in a second here. All right. So here we go. First and foremost, you're going to see that just, there's a design departure, of course, from many of our other products. I think our ID design is fantastic on all of our series boards, and we really have a very refined and clean design aesthetic that is present within our product. Really kind of with the Pro WS series designation, we want to have a clean and refined and minimal design language, right, which really kind of evokes the kind of professional target that we have with these series of users. So the focus here is really about productivity and performance and assured level of confidence in your platform. And you definitely have that with the WS series. I think for this generation, they absolutely look fantastic. Look really, really great in terms of the overall ID design. You will see some kind of similar hallmarks to maybe our ProArt series and some of our other WS models, where you see a little bit of things like right here, this nice little kind of translucent subtle accent there. There's no RGB lighting or anything like that that's present on the motherboards, but you'll see some nice little kind of design details that are present here just to add a little bit of additional refinement. Very kind of what we refer to as a kind of traditional ID design, where you can see there's still definitely an ID that's present, but really kind of taking a look at things like mechanical interoperability, assured performance in terms of the kind of the heatsink design and things along those lines, right? So we're going to go through and covering essentially everything here from the kind of the PCIe expansion. We're going to be talking about storage expansion support. We'll be talking about the IO configurations. All of that will kind of run through right here. So just for note, in case anybody's wondering, this is of course a brand new socket, and you will also correspondingly need to have new types of CPU cooling solutions. So you will see new types of CPU cooling solutions from partners. Take for instance such as EK. You'll see from Cooler Master, you'll see from Noctua. So there will be different types of solutions, but keep in mind that if you're going to be adopting a W2400, a W3400, one of our ASUS W790 motherboards, you need to make sure that the corresponding cooler has been designed for this socket and designed for the CPU accordingly, okay? Because the CPU will not come with any type of cooling solution. It's up to you to be able to integrate the cooling solution that you're looking for, okay? All right, so here you can see just a little bit kind of more of a top level view. So let's go ahead and begin to look at it right here. So you can see you've got 8 slots in terms of the overall memory configuration. And right off at the bat, you can see right here a very robust power delivery design. So this is going to be a 12 power stage based design. It's very performant. You can feel confident in terms of having stable and reliable operation, whether you're going to be talking about light bursty loads or whether you're talking about, of course, heavy multi-threaded workloads, which is really going to be the, of course, kind of target workflow and kind of work use scenario that you're going to want to have for these series of CPUs. We do have, of course, our ProCool power connectors. The ProCool power connectors actually feature thicker pins, which actually support higher current handling. They also have actually a reduced level of impedance, which helps to reduce the actual thermals within the actual pin-to-pin contact there. You'll also see some nice little things right here where they have some protective headers that have been added into the board. So if you're not utilizing it, just mitigates kind of dust, debris, and dander kind of settling from some of those contacts. You do want to make sure that if you're utilizing any corresponding headers, read through the documentation. You can remove those, put those in the box, and you are going to be good to go, right? So no issues in that regard. But again, in case you're wondering, that is referred to as our ProCool power connector. So these are essentially thicker solid pins that you're going to see present in here. And it is noticeable if you kind of look from kind of older generations, these will seem quite a bit more kind of thick and present and visible than you would have in a prior generation board, okay? So next here, let's go ahead and jump into the PCIe expansion. So you're going to see we've got 1, 2, 3, 4, 5. So 5 PCI Express expansion slots that are going to be present on this motherboard. So very, very robust in terms of the PCI expansion support. And keep in mind, you're going to see right here, these are all by 16 because of course you have extensive PCI Express lane support that's going to be on this motherboard. So extensive connectivity options. Again, you can put in anything you want here, from graphics cards to PCIe based storage devices to accelerator cards to multi-gigabit Ethernet adapters, whatever the PCI Express expansion card will be. And this will be also something else that I do want to note, that when we're talking about actually the WS series, they actually go through a very advanced, essentially, qualification process. And the qualification process is important because the value that we bring, I think, within the qualification process is, you know, when you talk about certain types of devices, they may not have what's called excuse me, they normal motherboard might not go through what's called complex option ROM support. So certain types of devices, they might have very specialized kind of option ROMs. So when that device starts on, it kind of has to initialize and handshake with the motherboard. And so more specialized kind of add-in cards, they are validated on WS platforms that which wouldn't traditionally maybe be validated on, let's say, like a gaming product, right? Because the likelihood of somebody maybe running like a quad gigabit Ethernet adapter, or maybe a specialized, you know, storage expansion card, right? A PCI Express storage expansion card. Those items might not be something that you would be running on here, right? Or a specialized maybe ASIC, you know, or certain things like that that you might run into the PCI Express. They might not be items that you would essentially traditionally run. So in the WS team, we do run essentially more extensive validation for these type of devices. So, and you will be able to find some of this information within the kind of QVL if that's something that you do want to find once that information is all live. Let me go ahead and put in the link here. Here for the board, and we got a question right here. Will any PCI Express storage card come bundled with this board or any other accessories? No, there will be a couple of very minor things. I think like the SATA cable, there's an actual CPU SIM guard, right, that actually comes included in there, like a Q connector, but no storage expansion. Now, you could entirely use our ASUS Hyper M.2 quad adapter card, so if you wanted to be able to supplement that, and we'll be talking about the storage options that are available to you on this board in a little bit, but it won't come bundled with this, essentially this board, right? So let me see, go back over. So where were we at? We were at PCI storage. So let me get back over here. So again, you have 5 PCI Express Gen 5 by 16 slots that are on here. These are also utilizing what is called our safe slot expansion design. So this actually expansion design is the specialized injection molded process. So it helps to actually improve the shearing kind of shearing force performance in all axes compared to essentially a traditional design. Some manufacturers, they kind of just put like a housing over the slot, and it doesn't really structurally enhance the integrity of the slot, but this injection molding process really adds structure and rigidity. So this not only helps to mitigate card sag, but overall just to help to provide a stronger performing slot. And this is going to be beneficial, of course, as you start to populate essentially more and more cards in there, and they're maintaining their weight, you know, over, you know, months and over years, right? So it just helps to give you a higher degree of confidence within the overall design, right? Okay, so let's see here. Now let's go ahead and go over to connectivity. So under connectivity here, we'll go to a back shot of the I/O here in a moment. So we're going to get a close-up shot right here to actually essentially go over all of our key I/O. So let me go ahead and bring that up here. Give me 1 second, guys. All right, here we go. So looking at the back in terms of the I/O connectivity, you can see that you've got a lot of USB. So 4, 8, 10, 12. So 13 total ports that are going to be on the back of the motherboard, right? You will also have, as you see, high-speed based ports right here. So you're going to have 10 gigabits, 10 gigabits, so that's already 4 10 gigabits, and then you have a 20 gigabits Type-C port that will be available to you. And keep in mind that if you are looking for, again, even more expansion support, those slots that you have on the motherboard, you can actually get like a 4-port 20 gigabit card, right? You can get lots of other expansion cards to be able to even supplement more I/O connectivity should you have those requirements with the PCI Express slots. And that's, again, one of the key benefits that you have within a WS platform like this, right? Well, we're going to talk about this under the PCDIY centric features just here because we are looking at the back I/O. You will see the board does have USB BIOS flash pack, which means that you can go ahead and update the UEFI BIOS and firmware. No CPU, no memory, no graphics card installed. You literally just need a flash drive and your power supply connected. You plug that into this corresponding port, push down the button, and it will low level update the UEFI firmware on the motherboard. There is a clear CMOS button. Traditionally, you wouldn't see this on WS series motherboards, but it is present because, again, both the ACE and the Sage will support overclocking with unlocked CPUs. So that will just help to kind of factory cover. And also for complex workstation builds, sometimes the clear CMOS button can be of value in terms of kind of helping you to troubleshoot or kind of get back to a working configuration if there's a parameter or some setting that you've set that is causing some type of post-based issue, so a power on self-test issue. For the connectivity, you can see 10G networking is going to be present on here along with 2.5G networking. So you have a dual LAN configuration. You will also have support for our ASUS Control Center Express technology, which is a form of out-of-band management and monitoring available to you. And then we have a high-quality S12220A audio codec, part of our Crystal Sound 3.0 audio design, which also includes an optical output. So if you want to go out to something, let's say like a receiver or like a sound bar, powered set of speakers that has optical input, that is going to be for your I/O connectivity. Okay. For networking there, again, recap, 10 gig and 2.5G. We are going to take a look here, though, at the picture of the board. Again, so give me 1 second to bring that up so I can see if I can show you the corresponding slot. So if you did want to be able to go ahead and add wireless connectivity, you will have that as an option for you. Okay, so here again, taking a look at kind of a bare shot of the motherboard. Again, you've got your slots right here, and you could easily go ahead and add in a wireless adapter if you're looking to be able to go ahead and supplement the board with wireless connectivity. Now, next up here in terms of the storage, right, we're going to see here in terms of storage that you've got your SATA. So there's SATA ports here, so 2 SATA ports, another 2 SATA ports, and then you've got slim SAS. Now we're going to go back to the spec page to be able to go ahead and denote here a little bit of the flexibility that you're going to have with the slim SAS connector. Now these are going to be PCI Express slim SAS connectors, and what that is going to give you the flexibility to do is be able to actually essentially have kind of multiple devices addressed into a single port. You can also go ahead and utilize ultra high density U.2 or U.3 based devices with a corresponding slim SAS to U.2 or U.3 based cable. This is going to be advantageous because if you want to be able to run very, very high PCI Express storage densities, then you will have that flexibility with U.2, U.3 drives, which, you can see, 15 plus terabytes available to you. So, significantly larger densities than you currently have available to you in the M.2. They also will generally carry the benefit that they have even higher performing kind of NAND in terms of their life cycle and endurance ratings. They also are not generally going to be thermally as constrained because the actual heat sinks within those drive designs are going to be larger and more dense. So the kind of the performance is you're getting a desktop class level of storage support. At the same time though, for users that do want to be able to, of course, kind of go with a traditional M.2 based SSD, when we go back here, you do have, of course, M.2 SSD support on this board with 1 slot right here. This is a full heatsink right there, so you'll have the flexibility to be able to go ahead and add in a PCIe NVMe M.2 SSD. Through this method, again, you could also go ahead and add one through the PCI Express slot with a M.2 to PCIe card adapter, or a multi M.2 card adapter. So there's a lot of different configurations for you to be able to kind of tackle how you may go about the expansion support, okay? Specifically in relation to storage there. So now you'll also see on that slot, I did note it there on the higher image. So here I just brought up this on the product page because it might be a little bit clearer. You'll see that there is going to be 2 designated M.2 slots. So you have one right directly next to the memory. So it's right here next to the 24-pin power connection. And then you have the other one, which is directly below the chipset. So those 2 heatsinks, once you remove those, will give you access to those 2 M.2 based SSDs. Those will be also supporting PCI Express Gen 4 in terms of their operating specification, right? So if you're looking for PCI Express Gen 5 support, the Sage will be actually offering PCI Express Gen 5 M.2 SSD support, or again, you could use a PCI Express Gen 5 M.2 SSD in one of the PCI Express slots. Now, I've gone over quite a bit there, so I'm just going to double check and see if there's any quick questions before we keep kind of moving on for some of these other points right here. Okay. We have got some nice points there, nice on the I/O. If you were buying this, so Safety Trousers is asking about the audio specification. So I'm not sure what you mean by outdated, and generally actually many users, if you check actually workstation platforms, pre-built platforms will probably be using a much more basic codec. The S21220 is actually very similar to the same ALC 4080 codec in terms of its operating specifications. And the way an audio codec works is actually it's affected largely by things like noise and proximity to other electronic components. So the rated performance specifications can actually be quite good if the audio design essentially accounts to help to mitigate things like EMI and other forms of noise, which is the reason why we call it our isolated audio design, or the Crystal Sound 3.0, because we have audio capacitors on there, we have shielding on there, we have an isolation moat that's in there, and overall it provides a quite competent design. And if you do actually compare this to some other competitors, right now other competitors are using an even older audio codec solution on here. Now I would say for workstation users, this is a very good and very solid audio codec that can be utilized. Of course, for some users, they may decide to go with a discrete based adapter, in terms of a sound card or a USB DAC and amp, right? An amp is actually more relevant than a DAC would be in many situations. So if that's something that the user decides, of course, you've got tons of USB ports, so you could definitely upgrade the audio if you want to be able to have it further. And you already do have that optical output for digital audio out. And as I also, and I believe you asked about HDMI, HDMI wouldn't be relevant because that's a digital based audio path. So if you, again, were using HDMI, you would be using maybe like, let's say your graphics switch has the ability to pass through audio through the HDMI. So that would be passed out to a receiver or a soundbar. But most workstation users are probably going to be running a basic set of headphones, right? And they're going to run that to the analog line level out, which is what would leverage the integrated audio codec. Or they might maybe use Bluetooth, which wouldn't even use the codec. It's literally going to use the Bluetooth and be passing it digitally. Or they might have something like a USB headset, which is like here, which has the actual audio chip, the hardware built into this. And again, it bypasses the analog audio solution, right? Because it is a pure digital design. So hopefully that clarifies your question there in terms of that. Okay. So moving things along right here as we get over to the Slim SAS, right? Again, you're going to have the flexibility to be able to have support for PCI Express connectivity. Now the ports are not all going to be PCI Express Gen 4. You will have ones that are PCI Express Gen 3 and PCI Express Gen 4. So you do want to take a look at the tech specifications, and of course your manual depending on the configuration. So for instance here, if I head over, you'll be able to always see this within the information right on the tech specs. So you can see like M.2 slots, it notes you right here that this supports up to PCI Express Gen 4, right, by 4. Same thing on the secondary slot, PCI Express Gen 4 by 4, right? And then here on the Slim SAS, you can see on the Slim SAS 1 supports PCI Express Gen 3 by 4. On the Slim SAS 2, you have PCI Express Gen 4 by 4 or up to 4 SATA devices, right? So again, that's where I was talking about. You can even have more supplemental storage, right? So if you add that via, in addition with the additional SATA ports, that would give you 8 SATA ports, right, that are available to you. And then you can see Slim SAS 3 would then give you also another PCI Express Gen 4 by 4 for support for something, like I said, a U.2 based device, okay? All right, so that is going to cover us in that regard. Okay, talked about there the audio design on PCI-centric design here. I do also want to note that these boards have been updated with our M.2 Q-latch design there. So the benefit is going to be that you're going to essentially have a simpler and easy experience when it comes to being able to install the M.2 SSDs. So if we take a look right here, we can see that you actually have a what's called dual contact M.2 heatsink design. This is going to be advantageous for larger density drives. So as you starting to get into these drives that are 2 terabyte, 4 terabyte, 8 terabyte M.2 SSDs, they can actually have NAND, so chips on the front and on the back. And this can actually needs to essentially have a dual contact to be able to ensure good thermal dissipation performance, especially under heavy sustained load. And so here you'll see that this slot has this dual contact design, but you also see this little latching mechanism right here. This is really easy because you can pretty much just angle in the drive, turn the little latch, and it will lock it into place. So it's a very, very simple process to be able to go ahead and install your M.2 based SSD. And that exists for both M.2 SSD slots. So this slot and the slot that's underneath the chipset both feature the Q-latch design, okay? Let me go ahead and move over here, and let me see, go over to our next portion. When we talk about also lastly there in the I/O connectivity, do keep in mind for the latest generation of chassis, because many of the maybe older motherboards, if you're coming over from an older HDT platform, a high-end enthusiast desktop platform, you might have not had an internal USB-C header. So this header is specifically designed kind of, it supplements the older USB 3 header, right? So here you can have up to, it's composed of like 5 gigabits, you can have up to 20 gigabits, so 4 times the speed. So if you have an external high-speed solid-state storage device, then you can connect that. Do keep in mind that your chassis does have to support this. So if you have an older chassis, it may not, of course, be compatible with this. If you have a newer chassis, many of the newer chassis that are on the market will feature this form of connectivity, so you can get up and running with that high-speed I/O. All right, and I think right here, we're going to also quickly touch on just the control center express technology. This will be present on the Sage model, but this is essentially kind of our out-of-band management or kind of remote management option. So there's a web-based UI that you have available here that will allow you to essentially have information and monitoring for the platform. You can do a lot of really cool things, like you can actually have advanced information. You can do updating via the board. If you actually have multiple systems deployed, you can actually see information regarding all of those systems in there. There is actually an activation card that comes included in the box, so you do actually have to install this. Beyond that, there's no cost to you. So normally in kind of some workstation platforms, it actually costs to have this type of functionality. So it's quite an advanced feature that, again, if you're looking for remote management and monitoring on your system, then you will have that available to you on this board. Okay. This is also, I think, probably still, it's pretty standard for ASUS at this point, right? The expectation, but again, maybe if you're coming from an older platform, the boards do have an integrated I/O shield. This actually not only makes just the build easier and simpler, and you don't have to forget about maybe the mounting the I/O shield, but you do actually have superior ESD and EMI performance because it's actually bonded there to the back. So it does actually provide an additional benefit to overall stability for the system to actually have the I/O shield integrated onto the motherboard. All right. Now, I think in terms of connectivity, I'm going to go back to my primary photo right here to take a look at the board because I know some users always have kind of questions regarding like the fan headers and things like that. So let's go ahead and just go a little bit closer, and we're going to go ahead and take a closer look at those kind of headers just to kind of get a sense of those things. Okay. So if we take a look right here, lastly, you're going to see you've got your CPU fan and your CPU OPT. So that, of course, is going to be kind of your standard for high performance tower heat sinks or kind of AIO cooling solutions. Or, of course, you can do water cooling as well, liquid cooling on this motherboard. So that would be for your primary fans that you can go ahead and run there. Now, in addition, you're also going to have chassis fan support. Now, this board does support our Fan Expert 4 technology. So that's our most advanced fan controls. That means you have fan controls within the UEFI firmware and also within the operating system. It can run a calibration to figure out the minimum and the maximum operating speeds, and then you can easily set fan curves, like you could set silent or performance. You can custom set a fan curve to your preference. And you also have temperature input mapping, which means that you could actually map your fans that instead of responding to the CPU temperature, you can actually have them respond to the GPU temperature, which might be hotter. But within a high-end platform like this, definitely probably the CPU under its workload will be the hottest running part. So it will probably be the component that you want driving essentially how your fans are responding. Okay. Now, when we take a look right here, we can see we've got another chassis fan header. You'll see chassis fan header 3, right? We'll go ahead and count that. We've got another chassis fan header here. And as we move down, another chassis fan header, another chassis fan header. So that's going to be 5, right? That you're going to have and right there. So if you total up all of them, you're going to have 5 chassis fan headers that will be available to you on this motherboard. So quite a number of fan headers that you can have supplemental for the chassis. And for some users that might be maybe using more exotic cooling, maybe larger radiator configurations, you can multiplex. There's enough power that's provided from each one of the headers. So if you want to run like 3 or 4 fans from a single header, that's entirely possible in terms of that type of setup. When we go down here at the bottom, you'll see that you also have the debug LED display that's available to you, a start button and reach high button and flex key. These are going to be a little bit more focused for those maybe overclockers that are going to be out there for performance tuning. So this is a start button that even if you didn't want to connect the leads in your chassis and you wanted to start it, you could start it via this. The debug LED is an auxiliary form of helping you to kind of provide more information if your system runs into some type of post process issue, or you're maybe experiencing some type of issue. Do keep in mind that you still also have the QLED lighting design, which is up here. So you have one for the CPU, the DRAM, the graphics, and the boot device. So there's one form of diagnostic LEDs here, another form of diagnostic LEDs here. And then the flex key can be mapped to different functions within the UEFI. That's the reason why it is referred to as the flex key. So you could actually have it work in a number of different ways. It just depends on what you define it within the UEFI firmware environment. Okay. So I think that takes care of our supplemental headers that we have here on this board. Let me go ahead and just go back and see if we have any questions there before we get ready to talk about the Sage. So the Sage will be the kind of the next model within this lineup. So give me 1 second right here. And I do believe I already dropped the board in the chat as far as the link there for the website. So again, if you kind of want to go over anything, feel free to go ahead and check that in the chat and you'll be good to go. And I don't believe I just noted it, but one of those headers there, from all the headers on the motherboard, remember you've got 2 CPU, you've got 5 chassis headers, and you also have a water pump header. So if you are running a dedicated kind of pump and reservoir, there is a dedicated pump, water pump header, which also supports higher power. All right. Why does the board have so many power connectors? So this is just because you're talking about a very high level, right? So when you talk about, you know, let me actually go back here. If we talk about our CPU, right, I think I have in the CPU design, right? Yeah. You're talking about, you know, 225 watt, 350 watts, right? And also a high number of PCI Express slots. So to be able to supplement power and assure stability for essentially the CPU when it's under very heavy workloads, or potentially if you're running an overclocked CPU configuration, right? Or you're running an extensive number of PCI Express devices, because again, the PCI Express slot in itself also provides power, right? Up to 75 watts. You may need to be able to supplement that power. So the manual will document to you kind of in configurations on which headers are kind of required and which ones are auxiliary and whether or not you would want to connect them. If you have a power supply that can provide all of them, there's no harm in connecting them all. So you don't need to kind of go like, will you damage anything if you were to run those corresponding headers? But that is the reason why you have essentially so many power connectors, is to essentially have stable and reliable operation under heavy load with essentially very dense configurations, right? When you're talking about PCI Express as well as the CPU and accordingly even the memory. Okay. Somebody's asking the Apex. Oh, this is focused on our Xeon and our W790, not Z790. So we already actually talked about our Apex. We have a dedicated live stream that talks about all of our Z790 motherboards. You can find it on our YouTube channel, or you can go ahead and check out our featured post and information in our PCDIY group. The Apex was also a limited edition board. It sold out and was no longer available, but we will be bringing back in a select number of inventory for March. So if you're interested in that, you can find it then. Okay. Let me go ahead and just see if there was any other quick question that might have popped in there. Okay, I don't see any question. Christian, I've covered that question in terms of your DDR memory. I don't want to tackle that here because it doesn't apply to these kind of platforms, but I've covered that in length in our DDR5 Insight post. So if you join our PCDIY group and you check out the DDR5 Insight post, it'll answer all your questions. And we also have a DDR5 OC live stream where I've talked about that as well. Okay. All right. So let's get ready. Next up, guys, let's take a look at the Sage. What do you think? All right, let's go ahead and take a look at the Sage. I'm also going to go ahead and bring up even a couple more photos for the Sage because I think it looks really, really good. So let's go ahead and take a look here at the Sage. Now you're going to see the Sage even goes to a larger form factor. So again, do keep in mind that if you're going to be adopting the Sage, right, just like actually our other Sage models, you want to ensure that your chassis has actually been designed for essentially this form factor, right? And so that it can accommodate this form factor and design. It is an extended form factor design here that you have, but quite robust. You can see again, you have a huge number of memory channels, that socket, and of course, 1, 2, 3, 4, 5, 6, 7 PCI Express slots that are going to be on the motherboard. So a very, very, very robust level of expansion support there. All right. Absolutely stunning. I really love the ID design on this board. Again, I think it looks absolutely fantastic, but let's get ready to go ahead and jump into it here. All right. So go ahead and bring up our product page and our images. So, and we can do a little bit of a side-by-side afterwards to kind of compare, you know, the two in that regard, right? So here is going to be the Sage board. You're going to see that the topology and the layout is, of course, a little bit different, right? Where it's opposed to having the memory being vertical, right, which is the traditional, here you actually have it horizontal, all right? So it's going to be on the top and the bottom of the CPU socket, right? And you'll see that that also kind of changes out a little bit of layout. But otherwise, most of the other elements are going to be pretty similar in terms of the overall, not only the design aesthetic, right, but the layout and expectation for a lot of the headers and the connectors and kind of everything that I've kind of talked about. But here we're going to focus in on some of the specific differences when you move over to the Sage. The Sage has really been designed, of course, for the W3400 series because you have up to 112 lanes. So that's the reason why you even have more slots. So compared to 5, you got 7 slots because you have more bandwidth, right? And you also have more M.2 on this board because, again, you have more PCI Express lanes. So again, having just more PCI Express lanes just gives you more flexibility for more forms of connectivity on the board, more slots, expansion, everything kind of just goes up because there are more options available to you. Okay. All right, let me go ahead and bring up the product page here, guys. And then we'll, in a little bit, kind of do the little side-by-side preference there. And I will go ahead and drop this one in the chat there for you guys as well. So give me 1 second. Okay, fantastic. So let's go ahead and take a look here. So still based on the W790 based chipset, again, socket, that LGA 4677, right? EEB is the designation there, that, right? Technically, if you talk about form factor, if you want to check your chassis, you can go down here at the bottom and you'll generally see under the form factor, it'll tell you. So right there, it actually tells you the EEB form factor and it'll tell you the exact dimension. So you can see 12 inches by 13 inches, or for our friends using, of course, in the rest of the world, right, you got your centimeters, right? So 30.5 centimeters and 33 centimeters. So check your dimensions. It is important to be able to ensure mechanical interoperability when it comes to the chassis. All right. So pretty much the same here, right? In terms of CPU support, again, you could technically run a W24, but this is really suited for the W3400 series. We move up from a 12 plus power stage configuration to a 14 plus 1 place power stage configuration. Very, very performant, high performance VRM heatsink design that's also on here. The heatsink is also making contact with this board for the 10G based networking to be able to ensure stability under heavy sustained load. You can see that you've got your two X710A2 10G LAN, right? So that's going to be quite robust because those are going to be those, again, high performing kind of server grades options that you have in terms of your NICs. 3 M.2 versus the prior board, which was 2 M.2. And this board also does step up by having 2 dual contact heatsink designs, right? And you also maintain the Type-C header just like on the other motherboard. But when we take a look here at the I/O, right? So you've got the 8 SATA ports versus the other board had less SATA ports, although it technically supported the same when we talked about the slim SAS connector right here. You have the 8 natively on the motherboard, and then you still also have the slim SAS connectors that are also going to be present there. So you have both of those available to you on the board. And just like in that other, in the other board we talked about, if you go over here, let's head over into our specifications. You are going to see though that the configuration spec is going to be a little bit different. So that M.2 slot and that both M.2 slots, the primary, so M.2 slot 1 and M.2 slot 2, right? Those are going to be PCI Express Gen 5 as opposed to PCI Express Gen 4 on the ACE. So if you really kind of want that dedicated M.2 slot with Gen 5 support, with Gen 5 drives coming out later this year, then you would want to go with the Sage. Now keep in mind, you could still have an M.2 SSD that's PCI Express Gen 5 on the ACE, but you would have to do it through an add-in card. Okay, so that is the difference here. Natively, you could run it on the Sage versus you would have to do it through an add-in card on the ACE. Okay, and then for that third slot, that one transitions to the standard PCI Express Gen 4 by 4 base connections. So again, you've got 3 slots that'll be available to you, 2 Gen 5 and 1 Gen 4. Now on the Slim SAS, you can see on the Slim SAS, both of those support PCI Express Gen 4, right? As opposed to on the other board, right? We had one that was PCI Express Gen 3, and then you also had PCI Express Gen 4, okay? So keep that in mind. And also again, while this board could run the W2400, you can see right here that there are some differences, right? Such as M.2, 1, and 2 will be disabled when a W2400 series processor is installed, right? So it is important to keep that in mind, okay? So let's head back over here and finish out these things. So we noted in the VRM, PCI expansion support, pretty straightforward, right? As far as 7 slots that we have on there, right? And these are all going to be PCI Express Gen 5 slots that are on this board. So it's going to be consistent in that regard. In terms of the connectivity, pretty much similar in terms of the connectivity that we had in the with the prior motherboard. Sorry, let me go ahead and readjust that right there. Maybe a little bit easier if I just bring up a raw image there. All right, so here you can see we've got the rear I/O. So you got 2 ports right there, another 2 ports, another 2 ports. So that's going to be 6 ports. Then you have 7 and you have 8. So that's going to be a 20 gigabit connector. And in addition to that, you're going to have your optical output, right? You got your USB BIOS flashback, and you have your clear CMOS. You have your out-of-band management dedicated port, because this also has a discrete hardware-based module on there enabling that, right? And you've got 10G and 10G. So 2 10G based ports that are going to be available to you on this board. So I/O configuration a little bit different than on the ACE, okay? Let me see. The Sage has a ProArt Vive. Yeah, it's actually the other way around. I would say the ProArts actually have a WS Vive, right? Because the actual WS series inspired actually the ProArt series. But definitely they have some synergy there in terms of the overall kind of ID design. Look fantastic. One other thing too that's really nice that I'll note here, it's a little bit off in terms of the connectivity here, so we'll switch back over to the aesthetic, is going to be that the Sage, being a much larger board, also does have a very, very large backplate. So the backplate, just because of the dimensional layout and the way that the board could be stacked, right, this just helps to actually add essentially torsional rigidity to the motherboard, and also makes it nicer to handle when you're kind of installing and putting this much bigger EEB based form factor board inside the system. So that is also something, it's subtle, but it's a nice kind of addition that you have there on the Sage versus the ACE. The ACE does not have a backplate on that motherboard. Okay. All right. Let's head back over here. And see right here, the power connectors, we went over that, our I/O configuration. We'll head back over here in terms of the kind of the M.2, right? And so this I already noted, there's 3 right there, right? With 2 of these being Gen 5. And again, all 3 of these are the Q-latch design. So Q-latch, Q-latch, and Q-latch, and dual contact. So that just means, again, contact for the NAND that's on the back of the M.2 drive and NAND that would be on the top of the M.2 base drive, right? And your Slim SAS connectors, right, are also going to be on here as well. So again, you can go ahead and go out to an NVMe based device. Again, that's going to be fantastic if you want to use U.2. I'm a really big fan of U.2 just because, like I said, you have much higher densities available to you. So instead of having to maybe kind of put like, okay, I want 16 terabytes and you doing like 3 M.2 drives, and also maybe having to be more challenged in terms of the thermal constraints in the power envelope, the U.2 is not thermally constrained and it's not power constrained, right? And you can get, you know, a 15 terabyte based U.2 drive or U.3 drive, or even actually go to higher density configurations that are available to you, right? Now, and I noted there on the rear I/O, that dedicated management port, that's because the board does have a baseboard management controller, right? So this is similar to the ASUS Control Center Express, but it has essentially a dedicated module in there that's available to you. And the ACE would optionally be able to support a more advanced form of out-of-band management with things like hardware level fan controls and a lot of other adjustment options through our actually out of band management add-in card. So it's a special card that plugs into the motherboard, has even fan headers and everything like that, so that it actually can all be accessed remotely independently of the operating system. So if you're interested in that, you can check out the website. We have all that information. But the overall experience through Control Center Express would be just like what we talked about with the ACE. Okay. All right. I think that covers most of those points there between those two. So let's go ahead and just compare them too. And then I'm going to lastly talk a little bit about some of the overclocking kind of notes in terms of some of that separation in terms of kind of understanding which models do and don't have that. And we'll kind of go from there. So go ahead and bring these two up right here. I guess we'll go ahead and look first at just the ACE and the Sage kind of side by side. So here again, you can see this is the Pro WS W790 ACE, and then here you have the Pro WS 790E Sage SE, right? And so this is going to be, again, really suited for the W3400 series, and here this would be more suited for the W2400 series. But technically, vice versa, you could run either CPU within either board configuration, but you would be seeing a difference in terms of some of the way the slots will work, depending on the number of PCI Express lanes based on the CPU. W3400 would always, of course, fully unlock everything, and it's best suited for this motherboard, right? Okay. And just taking a look here at the kind of the little bit of the raw layout. Let's go ahead and take a look here at this right here. And then we'll take a look at the I/O. Again, here a little bit of a side-by-side. The power delivery really isn't going to be a concern here in terms of the differential, but again, remember the power delivery is a little bit larger here, so this is going to be a 14+1 versus a 12+1, right? And here you've got one M.2, and then you've got your second M.2, right? These are going to be PCI Express Gen 4, and then here on the Sage, you've got one M.2, two M.2, and three M.2. So three M.2 on here, and two of these are going to be PCI Express Gen 5, and then this one would be PCI Express Gen 4, right? And then again, remember on slot layout, 1, 2, 3, 4, 5, 5 PCI Express Gen 5 versus 1, 2, 3, 4, 5, 6, 7 PCI Express Gen 5 slots, right? So that helps us to kind of compare between the two there. Lastly, let's go ahead and take a look here at just the I/O. Actually, we'll go the other way around there. Yeah, okay. So this is going to be the ACE, and this would be the Sage, right? So Sage will give you essentially 10G and 2.5G, and then on ACE would be 10.5G and 2.5, and then on the Sage you're going to dual 10G, right? And then you'll have both of them with 20 gigabits and 4 10 gigabits A ports. So they're going to be pretty similar in that regard, okay? You get a little bit more USB 2 ports on the ACE though, okay? Let me just see right here. What are the average read and write speeds on a modern U.2 drive? So you can actually have really outstanding performance. So you can actually have drives that are full Gen 4 based certification. So you can get drives that are 7,000, right? I mean, the reality is that sequential read performance is somewhat not really relevant because very few users, although in this field, we'd actually have users that are using much more sequential based performance, right? The reality of users actually your IOPS and your random performance, which generally is actually going to be under SATA speeds for a lot of desktop users, right? So we're only talking a few hundred megabytes, is going to be much more representative, right? But you can essentially equal the performance of U.2 to M.2. And again, remember, because you're not thermally constrained or power constrained, and because also many times the controllers are going to be more advanced, you can actually have more robust performance as the drive gets filled over time compared to an M.2. M.2 is a fantastic technology, but it was really designed for laptops. It wasn't designed for desktops. We just happened to see it at a time in transition within the industry that kind of I think the community fell in love with M.2 from a usability standpoint, where, you know, there's no cables to connect, easy to kind of slot in and you'll be able to good to go. But again, really U.2 and U.3 is the preferred option for desktops, but it has just not been commonly used because it was focused more in terms of general kind of component availability within the kind of the enterprise and kind of the professional segment of the market. But let me go ahead and bring up here, see. She did a post a little bit about this, and I can share this here with anybody in the checking out on the stream. If you want to find out a little bit more, you can check this out. Also, a great site you guys can find out more information is Serve the Home. Has actually covered a lot of drives there, but recently here I talked about this one from Micron, for instance. They're a great partner of ours. And here's an example of a U.2, U.3 kind of base drive that you have. So this is a 32 terabyte drive, right? You can now get up to 32 terabytes, right? You could not do that in M.2 because you're literally constrained by the density, right? And the power envelope, right? With an M.2, you'll be talking years before you can even approach anywhere near this. So you could have a single, right, drive. And keep in mind, you have, 1.5 million IOPS. And then if you want to be somebody that was just focusing on the pure kind of quote unquote sequential numbers, well, you can still see sequentially, right? That's 7,000, right? On your reads and your writes, right? For the 15 and 7,000 for the 30 terabytes. So you can see a 7.68 terabyte, a 15 terabyte, and a 30 terabyte, right? So you've got the 9400 Pro and the 9400 Max, right? And again, the endurance ratings are going to be far superior on here. So, I think the big value add that you have potentially with these type of drives, right, is essentially just the simplicity of installation, right, where you don't have to worry about like thermal pads, you don't have to worry about angling it in. Even though that is quite simple, it is going to be a much more simple, I think, experience, right? Literally, you put it into a tray, connect the power connector, connect in the cable, and you're good to go, and you have great performance, right? All right. Okay, so hopefully that answers your question there, the poets there. Yeah, so yeah, very, very large density in terms of the U.2, right, U.3 based drives. And there's quite a number of different companies out there that do offer these different types of drives. You will have, of course, a higher cost per terabyte because these drives generally are, like I said, more targeted towards the the enterprise market, right? But still a great option, I think, for a lot of I think professional users that are going to be out there. All right, let's go ahead and get lastly into some of the, I think, OC information right here, just so you guys have clarity on the product segmentation. So give me 1 second right here and bring this up. So this is another kind of big update and change, right, is going to be that you now have the overclocking support on XW series Xeons. So it's important to keep in mind, right, we talked about that we've got two Xeon series, right, with the 24 and the 3400 series, right? And if you see that it has an X designation, then that would let you know that essentially it is going to be enabled for overclocking support. Now, what do you get in terms of overclocking support? There's actually quite a bit of flexibility that you'll have available to you. In terms of that actual performance tuning option, you're going to have the ability to do things like Turbo Express 2.0, Turbo 2.0 and Max 3.0 tuning. You'll also have AVX offsets, adjustments, and other kind of power band options that can be tuned in there. So if you have essentially the thermal headroom, then you'll be able to kind of even maybe push the performance even further, right? So if we take a look right here in terms of the actual kind of configurations, Intel defines it right here. We have the mainstream platform with the W2400, right? Again, up to 64 lanes, and then up to 112 lanes with PCI Express Gen 5 on the W34, right? You're going to see that you have your unlocked. So your unlocked, take for instance here, would be like the W9-3495X, W9-3475X, and then you have here the W7, so the 3465X. So that's a 28 core, a 36 core, and a 56 core that will all be under unlocked based options, right? And then lastly right here, a kind of one that kind of sits right there in that mainstream enthusiast kind of for people that might be in Z790, but maybe still want really those high number of lanes, right? And they want overclocking support, then this could be an option here with the W5-3435X, because this would still be a total of 32 threads, right? So you'd have 16 cores, those golden cove cores, right? Going up to 32 threads, right? And then you would also have eight memory channels, right? So right here you can see unlocked, 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 and unlocked. And then here as we go into the W2400 series, you will also similarly have an unlocked base series CPU with the W5-2455X. So that's a 12 core, 2465X 16 core, 2475X 20 core, and then the 2495X 24 core. If you essentially do not see the X designation, that means that it does not support overclocking, okay? And both the ACE and both the Sage will be supporting overclocking in that respect. Okay. And lastly here, just to talk about, keep in mind that there is going to be some kind of factors that you want to account for, again, in terms of the clock frequencies, right, where there's going to be differences. Most of the base kind of Turbo Max 3.0 clock frequency across from like a W5 to a W7 to a W9 on the 34, it's going to be pretty similar. The most entry is going to be 4.6 gigahertz and then go up to 4.8 gigahertz. But your base frequencies could vary quite a bit more, right, depending on those cores and that sustained kind of load usage, right? So base frequency could be as little as like 1.9 to as much as like 3.2, depending on the model that you're going to be taking a look at. So that is also something to keep in mind. Okay. All right. Mario's asking, SlimSAS, yes, both the motherboards did have SlimSAS, so I did cover that on both of the models, so they both do have SlimSAS connectors, so you can go ahead and go out to a NVMe-based device. On the ACE, you can also go out to SATA, right, or you could also go out, like we talked a little bit earlier about, that if you want to use a SlimSAS adapter, right, to U.2, U.3, you could also go with a large density U.2 or U.3 based drive via the SlimSAS connection as well, so you do have that. No Thunderport, so I'm assuming you mean Thunderbolt, right? Yes, there is no Thunderbolt specification support on either one of these boards, okay? All right. That should ultimately, I think, give you the last parts there. I do want to finish kind of touching on right here. So outside, of course, the general UEFI options that you have available to you in terms of overclocking, you will, of course, have options with Intel's XTU software. So that is software that you can, of course, download directly from Intel to be able to place on the platform. And as I noted here, you will have options like mesh tuning. Mesh tuning is that interconnect technology, right, which is utilized, take, for instance, on the W-3400, right, in the EMIB, designed to essentially be able to improve like core-to-core latency performance, right? That's an overall kind of, let's say, efficiency kind of overclock target. And then you have with the Turbo Boost 2.0 and the Turbo Boost 3.0 technologies, right? That's more kind of a respective CPU frequency that you're kind of overclocking. And then here in terms of the offsets essentially just depending on your thermal loads, right? And kind of the workflows that you're running, offsets can be advantageous, one, to help to kind of manage thermal considerations, right? So essentially the moment that an application is utilizing those instructions kind of come into play, it essentially will offset the frequency, right? Because they could significantly increase the power consumption and the heat output. Inversely, also you could tune that if you have thermal headroom, right, you could adjust the offsets so that you could actually maybe get more performance. So you essentially have granularity and control to be able to tune how the system is running based on the power envelope and the thermal envelope that you have available within how you define your system, okay? All right, I think that overall wraps up pretty much most of our points here that we want to be able to go over here in this kind of first look preview on these two motherboards. So again, we've gone ahead and dropped the links there in the chat for those two boards. We do have, like I said, information already up in our ASUS PCDIY group. We'll have our product pages for ASUS North America up in the not too distant future. Make sure to stay tuned for future announcements in the coming month regarding these two motherboards in terms of pricing, availability, and more details when it comes to kind of this really robust and awesome offering that we have resident to W790 in terms of the chipset, and of course what Intel is doing with these latest generation Xeon based parts, whether you're talking about Xeon W-2400 or Xeon W-3400. And as always, if you're maybe more interested in the more kind of standard mainstream enthusiast, we have full live streams and a lot of other content that's available on our EdgeUp website, so edgeup.asus.com, as well as in our PCDIY group and on our YouTube channel and our social channels. We're covering the entirety of our current socket 1700 based platforms, so that would be like Z790 or B760, right, series based products, right? So we've got a full lineup in that regard to get you covered as well. So regardless of what you're going to be adopting in terms of the platform, we got you covered there. Let me go ahead and just see. I think we got one other question that came up right here, so let me see. So one last question: from the perspective of motherboard manufacturing market leader, will RJ45, 25 gigabit and 40 gigabit ever become a thing? Yeah, so that's actually something that we have discussed. We've just started to finally see, I think, a reasonable amount of feedback from certain kind of verticals. So part of the factor is really a huge cost. When you go over to 40 gigabit or even like 100 gigabit, or as you noted, 25 gigabit, one, you're just significantly increasing the controller cost. And two, I think offer, robust kind of competitive pricing within the marketplace, right? I think 10 gigabit is a good offering, right? And it still can meet a wide degree of users. We really only see like 25 and 40, and then of course, if you move into like 100, really for specialized verticals. And so like in discussion, take for instance, like video production houses, right? That are doing VFX, they have like specialized cards and configurations where they really want even more networking bandwidth, right? But they also have the infrastructure that merits that, but they can also easily add in they can add in a Ethernet adapter, allowing them to have those speeds. So we think that's still the best option, but I do think that we are currently discussing for future platforms that you may begin to see a transition in select models, especially in something like a Sage series model, maybe finally starting to see something like a 20 or 40 gigabit based offering, because we are starting to see at least a reasonable amount of penetration within certain segments of the audience that are taking advantage of that. So you would probably see maybe a transition to something like a 10G to standard based connection option for the majority of users, right? And then maybe have an ultra high speed offering with like a 25 or like a 40 gigabit. So not right now, in terms of any immediate products that have that, but that is something that we are evaluating for the future. So hopefully that answers your question. More peanut butter and gets you covered there. So for anybody asking about any other models, at this time, these are the only W790 models that we have to detail. So if, of course, anything changes, as always, if you're watching out our ASUS social channels or part of our PCDIY community, then you'll definitely find out about the latest and greatest offerings. We also have a weekly live stream on Fridays that covers all the latest and greatest from ASUS regarding the entirety of our product portfolio, including our W series product. So if you're kind of interested in finding out about new options that we have, then you can always join us there on Fridays and find out about the latest product introductions. And you can also feel free to ask any questions if you're, again, not part of our PCDIY community. All right. So I think that covers everything. Thank you guys so much. If you guys, again, have any other questions or comments or feedback, feel free to go ahead and drop them in the comment section. We'll see if we can go ahead and follow up that on the YouTube if you're checking us out there. If you're checking us on Twitter, you can't do that, but you can make sure to go ahead and, like I said, check out our links to our PCDIY group. And if you're watching us on Facebook, you can also drop us comments there and we can see if we can go ahead and check those out. Or again, make sure to check out our PCDIY group. All right, fantastic, guys. Take care, take it easy, enjoy the rest of your day, and best of luck with your builds.